I go to the next one. Maybe, sorry, I forgot to activate this. If you need to scan this, you can scan the QR code here. All right, so let me move on to the next one. In fact, we want to have the equilibrium state equation based on the previous step, actually the state transition diagram. So we will have the equilibrium equations, and so that we have the form, this one. Oh, we want to have a probability here. It's a probability. Step probability, having I customer in the system, and we have the equilibrium equation. But right now, I want to let you know how to have the equilibrium equation, and so that we can have the formula here. Once we have the formula, then we can derive the results. So look at this. We have a 0, lambda, 1, maybe to I use I. And we have I and 2. Oh, thank you. We have a lambda, and we have a mu, and we have a perhaps I use I minus 1. All right, so we should have the state transition diagram like this, right? If so, then how to have the balance equation? Actually, for the current result, we based on this, a circle. Approach 1 use a circle. With a circle, then how to have the balance equation? Or maybe the equilibrium equation. In fact, we want to check, oh, rate. Actually, these are rate. And these are rate. And I don't mention the rate. This is arrival rate. And this is the departure rate or service rate. Right? Arrival, so we have a force to come to the system. So this is arrival rate. And another direction, we have the service rate and departure rate. Service once finished, and then the customer can leave, and can leave, then it will depart. So it is called the departure rate. Well, so if we have a circle and the rate, right now we have the two rates, arrival rate and departure rate. But for a circle, we can have a rate out and a rate in. So that balance, we should have a 0 net rate, right? 0 net rate, it says we should have the rate out equal to the rate in. All right, so rate out equal to rate in, so we have this. Sorry, maybe let me redraw it. So I simply emphasize I minus 1 and I plus 1. Well, if so, we have this. Rate out. So first of all, rate out. is equal to this. P of I probability multiply lambda and multiply mu P of I. It's rate out. And how about rate in? We have this. And set the two rates to be equal, and so that we have the balance equation, right? So currently, is it okay? If it is okay, look at this. The second one, right? So here it's rate out, and the right-hand side is rate in, am I right? But we have a special case, the first one. So currently we can have this. Why we have the first one? Why we have the first one? If we have this only, oh, okay. So anything wrong? So how to have the first one? I've checked the second one. But right now, let's check the first one. The first one is 0 and 1. So we have a lambda and we have a mu. And likewise, we can have a circle. But the circle only focus on 0. 0, so we have a rate out. It's this. And rate in, we have this. 1, so it's mu. So that we have this. Right? And you can check this is the first equation. All right, based on the first equation and second equation, they are balanced or co-equilibrium state equation. Based on the two equations, then we can derive this one. All right, so we already have this one. It's the first one to have the result. How to solve it? Recursive formula. So you can base on some concept from discrete mathematics and recursive formula to have the result. You can try this concept, how to solve it. However, let me have a quick way to have the result. Then we have a 0, 1, maybe to I minus 1, then to I plus 1. I ignore the other, simply have these. Previously, we use a circle, but second way, we use a line. Or maybe it's a plane. All right, so how to have that? We have these. A cut, it's a line. So which one we use it? Perhaps this one. Or maybe this one. Okay, let me try this one, the second one. So if this one, we have a line, so that line will have to rate to the right-hand side and rate to the left-hand side. So here, rate this side. So it's equal to this. And how about rate to this side? If we consider they should be equal, so we have this one. And finally, the balance equation should be this. All right. Actually, maybe it's my fault. We should choose the first one. The first one will have the generalized one, but it doesn't matter. We have the general equation based on the current way. It's a cut. If we have a line, finally I should ask, the current one can be generalized to the other cuts. Yes. You just try to change the index. And so that for the current system, we should have this. We should have this. Oh, okay. Right now we have a lambda pi and mu pi plus 1. Actually, we focus on this. Pi plus 1 larger. It's equal to lambda over mu and pi. All right. And in fact, we can have the others. Pi equal to this. Actually, we can start from this. If we start from this, let us have this one using rho to denote this. Oh, okay, I start from this. It's rho, but this one equal to it's rho again, it's I minus 2. So we have rho square pi minus 2. And you can continue. 2. So it should be I minus, it should be I minus I, so we have rho I p of 0. Is it true? So back on the current way, the second way we have the relationship, and this relationship actually this one. Am I right? Therefore, you can base on the current equation using recursive formula so that you can have the solution. Or maybe you can base on the quick way. We use a line and so that, or a plane, so that we can have the relationship P of I equal to rho raised power to I and multiply P of 0. All right, so either way we can have the solution, but we base on the solution to continue to have our performance measure.